All right. Well, hey guys, how's it going? This week is going to be a relatively quick and dirty lesson. We don't have a whole lot going on. What we're going to be doing this week is we're going to be doing drawings of assemblies. As far as assignments go, well, we've got the one that we're doing here in class or in the lecture. Then we also have a one for the ball joint. Now, the ball joint is just going to be a portion of the stuff that we're doing here. We're not doing an exploded view on the ball joint. We are doing an exploded view, however, in our links assembly, which is what I've got up here. So, first of all, to get started, let's go ahead and open up your link assembly. It will make things a lot easier if you have the assembly open, because we will be needing to use the assembly file to actually create our finished piece for our drawing, because as I said, we are going to be doing an exploded view here. So for exploded views, there are a couple of primary reasons that we use exploded views. We use them to show the orientation and the way that a component goes together. We use it to show components that may otherwise be hidden, but mostly it's to help the end user understand in their brain space up here what the actual assembly orientation is for everything. And what I mean by that is, here in the links assembly, we have two different pieces. We have, for the pins, we have one piece there, one piece there. One's an alignment pin, one's a pin head. So what that means as far as the actual assembly goes, we don't, it's very difficult to actually explain to people that. But with an exploded view, we can actually move those components out from their original location, show the path that they're actually going to be located on, and then we can better portray that information to the end user so that they then can go and more easily understand what the finished product is going to be. So to do this, we are going to start off in our assembly file here. We're going to go ahead and create our exploded view first, and then we're going to go ahead and insert that into a drawing and pull up a couple of the different things that we create inside a drawing using all of this. So assembly drawings can be done in a lot of different ways. They can contain a lot of different information. You will always have item numbers. An item number is just a number that references each one of the components that will reference that in a list somewhere. That list can be on the sheet itself in the form of a bill of material table on the sheet. It can also be a completely separate sheet that is maintained outside of the Solidworks model, giving you a little bit of flexibility as far as ECNs for part numbers and stuff, and drawing revisions. But what we're going to be doing with this class is we are going to be placing the balloon numbers on our form, and then we're going to be placing a bill of materials on the sheet as well. So to do that, we need to be able to clearly and plainly point out each one of the finalized components. Usually at this point I would show you guys a drawing from work that I brought in, but it's kind of hard to do that because I haven't been into my normal day job in about 3 weeks, and I've got to get permission to show you guys that stuff anyway. So instead, we'll just go ahead and hop into it. So make sure that you've got your links assembly open, and we'll go ahead and get moving. Now, if you remember, in our links assembly, we created a couple of mates to kind of derive where this thing was going. We're just going to attach this and pull it all the way up there on top. So what I'm going to do, I'm just going to give this a little bit more of an arc here. It's just to show that it doesn't need to be as rigid. Because we're dealing with a loose assembly here, it doesn't matter that much. The majority of your assemblies will be 100% tied down, and you won't need to modify that at all. It will be what it is. But for us, we're going to go ahead and do that. So next thing we need to do is we need to determine a good view that we think we're going to use for this. Typically speaking, if you hit your spacebar, it's going to bring up your view cube, and you can just hit this corner right here. And that'll give you an isometric view. Usually isometric views are going to be optimal, but you have a couple of different isometric views to choose from. I'm going to pull this window down here, and if you click the drop down next to our isometric view, you can get all of our isometric options. We've got isometric, diametric, or trimetric. And those are just different different angles that you're looking at the thing. So an isometric is basically a 45-degree angle off to the side and then 45 degrees kind of towards you. It's kind of splitting the difference of all of those. If you see on your view cube here, it's that corner of the view cube, so you're looking down from what would be the corner. Diametric is taking it from more of a frontal angle, and then trimetric is kind of a combination in between those two. I'll give you an example. So this is isometric here that we're looking at here. You can see that it's looking, we've got a lot of the top on this view. So from there we can go ahead and go diametric. You can see we don't have quite as much of the top now. We have more of a front view. And then if we hit it one more time, we hit that drop down and go to trimetric. Now we have kind of a combination of the two. It's a more front view, but we do have more of the top than we did on our normal diametric view. So for this particular one, I actually like trimetric a little bit more. It gives us the ability to see the top, to see the stuff that's going to be on the other side, while at the same time not going full on like way big from the top. It gives us a little bit more of a view of what this thing's actually doing. But it doesn't really matter. You guys can go whichever one you want. The isometric will give you the ability to see the stuff on the far side a little bit easier, but kind of loses a little bit of that depth as far as our finalized shape goes here. So once you select one of those, we need to go ahead and start our exploded view. Now the reason that we selected that before we start our exploded view is because the exploded view, where we move all of our components, is going to vary greatly dependent on what your view is on your sheet. Because you want to move everything out in this exploded view. Well, so I guess I should rewind slightly. An exploded view is where we're actually going to take each one of the components that is building this. So we've got like the two pins, the alignment pin and the pin head, and we've got the single link, the double link. We're actually going to move them out to show this in an exploded orientation. We're going to kind of move everything apart from each other. Now, we are going to then add, they're called, why can't I remember what they're called? I don't know, it's been a day. There's exploded lines then to show the actual path that these would have to take to get into their final location. So another good option is when you've got the chance to, don't explode all of the things. So like we've got here, you can see we've got one pin set, two pin set, we got a double link here, single link here, double link here. Then we've got all these all the way down. In this case, I'm not going to explode all these all the way down. These are all identical in orientation to what these are. So what we're going to do is we're going to explode this double link. We're going to explode this pin set, and this single link. Because we want to do this in a way that is it's conducive to actual physical real life. We're not going to move this in a way that isn't able to actually be taken care of. So I'm not going to do this double link here, because if I did this double link, I would then have to remove this pin set, and that's just too far. That's more than we need. We only want to do the amount of explosion that is necessary to actually get our point across, convey our story of what this part is. So let's go up here on the top, up here in our ribbon. We're going to be on the Assembly tab in our ribbon. We're going to go about 2/3 of the way across and 3/4 of the way across. And we're going to hit Exploded View. Now this is going to open up a new tool. We can see our tool on the left-hand side here. We've got an exploded step up here on the top. The way the Exploded View works is it's going to actually follow a step-by-step process of what you click on and how far you move it. Now, you can, once you click on something and you move it and you let go, you're done with that step. You can go back and edit that step, but anything else you click on from that point, unless you're editing, is creating a new step. And I'll show you what I mean here in just a second. But in order to keep your exploded view clean, able to be worked on by other people, and simple enough that you can go back and make changes later on, because you will need to go back and make changes, we want to keep it to as few steps as possible. So if you're moving a component out 2 inches, you want that move to be done in one move. You don't want to move it out 1.1 inches and then move it again 0.9 inches. You want it set right at 2 inches. So over here, we've got, this is the name of the exploded step. We're not going to be playing with any of the names, but you can rename them. Right above that is the type of exploded. We've got regular step explosion, which is just going to be a linear translation based on the X, Y, Z coordinates. Next, we've got a radial step. So in this one, you're going to select an array of components around a center point, click this, and then it will expand them all from that center point. This is useful when doing things like bolt circles. However, you can't do this instead of pulling the bolts out and then expanding them. This has to be done in conjunction with a linear translation. A translation, by the way, when it comes to movement, translation is just a straight line uniform movement, typically along one of the axes. It doesn't have to be along one of the axes. It can be, at an angle to an axis, but typically speaking, it's in line with it. All right, down from there, we've got our selection pane. This is going to be the parts that we've selected. And then from there, this is the explode direction. So let's go ahead and start moving some parts. So I'm going to click on this one right here, and I'm going to pull it out. Actually, I'm going to do, all right. So I'm going to click on that, and I'm going to pull it out. Let's hope that didn't create two. It did not. However, it did select our sub-assembly here. Now, we actually don't want it to select our sub-assembly, so we're going to have to do this a little bit different. We're going to get rid of that. We're going to go back. Let's get rid of this step really quick. Delete that step. Okay, so the reason that it pulled that out as a sub-assembly, and it may not on your guys because you guys are getting a different assembly to be able to explode this from. If you have a sub-assembly like that and it clicks and it tries to drag out the entire sub-assembly, what you'll need to do is come up here to expand this sub-assembly. Then we want to highlight the sub-assembly that we want to move. And this one right here. We're going to expand that. And then we've got two different ones. We've got pin head and alignment pin. Let's click on alignment pin. And now we should have just one of them. You can see that it's just that alignment pin. Okay? So that's kind of the long way to go about it. If you don't, if you click on it and it doesn't try to pull out the entire thing, there you go. You're good to go. You'll get this point. If it does try to pull out the entire thing, like if you're using your own Links assembly, or if it just does it, you'll have to go into the model tree like we just showed you, go down, highlight the actual one. Now, the reason that I knew that was that one is because as you hover over these pieces inside your model tree, you can see on my actual screen, there's an orange box that pops up around the subassembly that I'm hovering over. So now I need to do the pin head, which is the other one. So I pulled that one out and I dropped it. I let go and now it's moved. So now if I click on another item, oh, no, they changed it for this year. Sorry, this is the first time that I've done assemblies within 2019. We're still in 2017 at work, which is, don't get me started on that. But, okay. So we've got our pin pulled out. Cool. We've got it in the Z direction. That's fine. We've got our distance here. Let's change that distance. Now, we can move it around a little bit and try to hit about 2 inches. Or we can just come over here, click at this distance section, 2, enter. Now it's at 2 inches. We can hit this button here, which is going to flip the direction of the offset. You can see when I click it, it's going to go over to the other side. We don't want it on the other side. We want it on this side. So we're going to leave it over here. And now we're going to hit done. Hitting done accepts that change. It places that explode step up into our explode steps up here. Oh, done. There we go. And now we are ready to continue on to the next step. So the next step that we want to do is we want to actually move this guy here. But remember, if I click on that, it's going to click on the entire assembly. I don't want to do that. So I'm going to come back over here into my tree. I'm going to go all the way down. I've already expanded this so I can click on just the pin head. And now I'm going to go out the other side. Now I can go approximately the same distance at that 2 inches, or I can go not quite as far. It doesn't really matter. What I'm trying to do is I'm trying to orient these in a way that I can see them from the view that I'm looking at right here. because once we put this on our sheet, on our paper, we're going to need to be able to see all of this stuff, obviously, without rotating around our model. Because if you have to rotate around your model, you're not going to be able to see it in the sheet because you can't move the stuff in a sheet. Okay, so I've got this one moved out. It's moved out at 1.429, so let's just go 1.5. I like modifying these to rounded off numbers because round numbers are pretty. They're just easier to organize, easier to keep track of, easier to maintain, and it's easier to uniform. So if you need to move other things out at approximately that distance, I know that this pin head is moved out at 2 inches, this one is 1.5 inches. So now I'm going to go ahead and hit done, and I've got those 2 pins moved out. The next thing that I want to do is I want to move this link. Now I'm going to move this link in this direction right here, the X direction, basically pulling it out and away from the model. Now, the thing about that is, if I do that and I leave my 2 pins that we just moved right where they are, it's going to look like those 2 pins don't interact with our link. So those pins are actually going to need to go with our link to remain properly oriented in the spot that they need to be. So let's go ahead and click on those. So now we've got all of our components. We've got our 2 pin heads. We've got our double link. Now if I click and pull, you can see it's going to pull that out. Okay, let's go to about there. Okay, so now we've got our 2 pins out. We've got our double link out. And we are done with that step. So now over here you can see we've got 3 exploded steps. We've got explode step 1, explode step 2, and explode step 3. We're going to go ahead and end this video, and when we come back, we're going to go ahead and move the remaining 2 links that we're going to use in our exploded view. The remaining 2 pin heads in our exploded view, and then this link right here. So, go to the next video for that.